Okay, so
Okay.
we were here.
Yeah.
Like I said earlier, the accuracy or the F score was boosted about 3%. So there is another way to give it another boost, which is hyperparameter tuning. So in this, we're going to try to parameterize or tune our parameters in the models. So every model there are some parameters like random states, the number of estimator, the number of max depth, and so on. So each model has its parameters, own parameters. So, for example, for random forest, there is some parameter like bootstrap, the max depth, the number of estimator. So we'll try to fine-tune these parameters with the help of the grid search cross-validation, which is a grid that's going to search each parameter, like for example true for the bootstrap, also max depth, which is 5, and so the estimator is 500. It's gonna do some trial with this parameter. Also, it's gonna try to use other trial with the same parameters and the other example like false, 10, and 1000, and so on until it's going to get the best features. So, for example, to do that, we're going to use the random forest classifier. We'll try to use the grid search with the estimator, which is around the forest, the parameters which are this parameter grid, and for the cross validation, which will be 2, and the number of jobs, which is all the CPU. And for the verbs, we're going to give us all just the print of each steps. After doing this grid search, just for information, this grid search is exhaustive, so it can take all the resource of your PC or your notebook. So try it at safe. Use some small amount of these parameters, and also if the data is very huge, it's gonna exhaust all your parameters or all your resources. After this grid search is completed, we got the best parameters, which are bootstrap, which is true, the max depth, which is 15, and the number of estimator, which is 1000. So to test it, we're going to use the F score, which with the Y test, and the best grid search prediction. So it got about 85%, 0.6. And for let me see. So run. I will go into RFC, which is a random forest classifier with which puts us about 85%, 3%, while RFC with root feature selection quotes us about 85.24. So there is a small difference, which is about 0.40%. So it is a better accuracy than the other. So to resume our model performance comparison, we're going to create a data frame. We're going to have the exponent number with the exponent name and the F score. First, we use the logic segregation, which goes about 78%. Random forest just normal, which got us about 82%. Random forest with Volta selector, it got about 85.24%, and with the hyperparameter tuning, we got about the 85%.63. So it is clearly observed that how the F-score increased from logic regression to random forest with selected feature. Then again, F-score increased with hyperparameter. Also, this is one of the approaches we can try to solve our problem. There are many, so you can use this or other models. Just check the scikit-learn models and try to solve them, to use a model. We could also do some standardizing and normalization of our data. So our data is not normalized. So there are some variables that are ranged between 0 and 1, some variables that are ranged between 0 and 100, some variables that are, so there are many, there are different scales between each variable. So if we try to use normalization or standardization, we're going to scale data between 0 and 1 for all the variables and all the columns. So this is an approach to improve our accuracy. Also try doing some decision tree, which is another model of like random forest, which is also robust to use it. So this is end-to-end how to build a data machine learning project. I didn't, well, like we said in the title, is an introduction with the PyTorch and TensorFlow. So I try to go on.
Okay, Ayoub. So because you will have a call right now.
Yes.
So we will do one thing. We will try to break our meeting right now, just to let to the participants the occasion to prepare some questions about all the previous content. Okay. And then you will try to do your call, and let's be back on maybe 11.
Okay, sure.
Yes. If that's work for you?
Yeah, it's work. Yeah.
Yeah. Okay. So please, dear participants.
Okay. Let me share with you this notebook.
Yes. Okay. So Mr. Ayoub will share the notebook on GitHub. So you have right now half an hour, 30 minutes to start the notebook and to see all the content and to prepare your questions. Okay, so you have about 30 minutes to prepare your questions. Okay, and we will back at 11 o'clock to resume our meeting and to try to respond to all your questions. Okay. Yes. Okay. So hope to have all the participants at 11. So please be there. Okay.
Okay. Thank you, Kara. We'll be back.
Thank you. You really appreciate. And so sorry about interrupting you. Yeah. Okay. Good luck for your call.
Thank you very much.
Thank you.